Hi everyone. Um, I hope you went through the previous video of three-way handshake and how that works. Today we'll be specifically discussing about um, a very basic concept of networking again, which is the OSI layer and the TCP/IP model. How different the TCP/IP model is from the OSI model. Um, and these are the very two common models that were designed for data communication. Whenever a machine in computer networks wants to communicate from one node to another, they need to have some kind of model, they need to have some kind of protocols. Protocols are nothing but a set of rules designed in a way that perform a specific task at each layer, right? So let's talk a bit about OSI layer first. And if you guys feel like I'm not able to remember all the layers um, uh, side by side, or like layer by layer, I'm not able to remember the layers. There are many jargons that you can search online to remember it. The simplest way that I remember it is um, APS NDP, right? So this is some way for me to remember all the layers. um, but yeah, there are multiple other jargons that you can create out of these layer names and come up with a way to remember them. But what is OSI? OSI stands for Open System Interconnect Model, um, which was created by an organization called as ISO, because there were so many issues that were happening previously during the time of data communication. When everything was getting created, there was no uniformity, so someone had to come up with a uniform method, a uniform way, a uniform model. And that was one of the primary reasons why um, OSI model was created. So there are seven layers. Okay, one is application layer, um, one is presentation, um, one is session, then we have transport, then we have network, then we have data link, and the last but not the least, we have physical layer. Okay, I'm so sorry. The whiteboard is somehow auto correcting my text. Uh, but yeah, so these are the layers that we are going to talk about, right? Um, so talking about the physical layer first. um, the physical layer is nothing but, consider that you have a computer or a laptop which has a LAN card in it, right? It will have something called as a NIC interface, network interface, on which you will use some kind of cables, like you can use a coaxial cable. There are RJ45 connectors that come in, which you connect with your laptop or computer to connect to a LAN, um, or any specific network. It can be an internet. Your physical connectors will also have something called as Wi-Fi, which you will use to connect to public internet, Wi-Fi hotspots. So think of physical layer as nothing but a hardware connector in your machine, which is enabling you to connect physically to a network. right? And physical layer has it deals with the bit streams, which are nothing but 0 and 1 binaries, numbers. There will be streams of data going through the physical layer, which would be in machine language. So we won't be able to understand any of those bit streams that are going through the physical layer. But yeah, so physical deals with the actual data bits transferred over the network. And similarly, on the other hand, where the receiver on the physical layer will receive these streams of data and then send it across the topper layer, the topmost layer, to process that data, right? So yeah, from the sender side, physical layer will deal with the streams of data. Data link layer is nothing but every device that you have physically present should have an address to identify itself, right? So think of data link layer deals with those addresses, which we call as MAC address. um, and every NIC card will have its own MAC address, and those MAC addresses are created in a random fashion in such a manner that each device will have a unique MAC address globally, which no other device would be able to replicate. Okay. So think of data link layer dealing with MAC addresses, and there is something called as um, a protocol called as ARP, which stands for Address Resolution Protocol. And there are like broadcasts that happen using the ARP protocol in order to resolve the physical MAC addresses of devices within the network, so that each device knows that, okay, if I want to communicate to machine X, right, I need to know what is its physical address so that I can communicate with that machine. So the sender will send a broadcast of ARP, which will go to all of the machines that are present on that network. The receiver who has that physical address will respond that physical address with a response packet in that ARP request, saying that, hey, I am machine X, I have this physical address, you can reach me using this address, right? uh, Network layer is layer 3. You must have heard this terminology very well, where everyone is saying that, okay, router is a layer 3 device, right? So when they are stating layer 3, they are stating about network. And uh, you can read more about collision domain and broadcast domain in order to see how network and data link layers devices are different. Data link layer has, I can give you an example as hub. There are hub devices which work on data link layer. Network layer has a protocol called as IP, or Internet Protocol. These are the logical addresses or the IP addresses that will get assigned to the devices, with which we can route the traffic through different networks. So let's say that you have one network within a company, and you have a collaboration with some other company which has their own network, and you want to communicate with their network. You need to set up a layer 3 connectivity between those two different networks with two different subnets in order to communicate, right? So routers come in picture when you want to communicate between two different networks having two different subnet ranges. And you can read more about what are subnets. I won't be going into detail because every topic that I'm writing here, that itself can have like bunch and bunch of data that I need to share, and it can take hours of communication. So if you guys feel like you want to get a more detailed video with respect to any of the topics that I'm writing here, feel free to give me a comment on this video, and I can go ahead and create a video for that specific topic separately. All right. So transport, we already talked about TCP and UDP, which are the transport layer protocols, and it deals with the transportation of the data throughout the network. Uh, and session layer deals with establishing, maintaining, and terminating the sessions of communication. Okay. Presentation layer deals with how um, the data will be presented on the machine, what would be the security mechanism, and a few other aspects that you can read about online. But it deals with how the data would be presented towards the application layer. Application layer is the layer that we are able to see, um, and there are various protocols that work on application layer, which we use day in day out. Okay. Whenever you are browsing some web pages on internet, we are using http, https, we use DNS, um, and many other protocols. I can think about like SMTP, which we use for mail servers, um, and various other protocols. Okay. So this is like OSI model in a nutshell for you guys. And um, this was a very good layer that was designed to bring uniformity, but it couldn't work well, which is why they had to come up with a more practical approach layer, what they call as TCP/IP. Okay. So TCP/IP is nothing but, you can summarize these layers into four layers, where you have the topmost layer as application. um, this layer consists of all the features of application presentation as well as session layer. Then you have transport, then you have network, then you have link layer, which is an amalgamation of the physical as well as the link layer both, right? So there are various advantages of the TCP/IP model over the OSI model. So what happened in OSI model is there were some disadvantages of OSI, which were like, if you wanted to fit a new protocol inside that model, it was not possible, and it was more of a reference model than an actual practical implementation model, right? So they had to come up with something which they could practically implement, which is why they came up with this layer, which has like many routing protocols that are supported here. This model is highly scalable, and it uses client server architecture, and it is very lightweight layer to code on or design on. um, there are some disadvantages to TCP/IP model as well, like delivery of packets is something that is not guaranteed by the transport layer here, which was there on the OSI layer. It is vulnerable to synchronization attacks. You can read about these terminologies online if you want to know about them in more detail, or you can give me a comment on the chat box and I'll be happy to create a video for them. um, but yeah, mostly we use TCP/IP model practically everywhere. um, and yeah, that's pretty much it about TCP/IP and OSI layer in nutshell. Let me know if you feel like you want to learn these layers into more detail, and I'd be happy to create a very detailed video about it. That's it for today, guys. Happy learning. Bye bye.